This shit my favorite song. You just don't know the words, but I still fuck with you. You just ain't never heard. It go like count that stack, rock that captain down.
Alright, so now I want to go over a different kind of, again, our Leibniz notation. So this is another way we're going to write the chain rule, but this time using Leibniz, right? So our D's come into play here. So as I've introduced already, y is equal to, let's say our given function is an f of u, okay, where u stands for g of x, so f of g of x. These are all the same, okay, when you see them. So if we were to have dy dx, this could be the same thing as f prime of u times u prime, okay, and this would be of x, or whatever u is in terms of. Okay, and then this is also equal to, so I'm just following it here, so if we differentiate everything with respect to x, this is that, that's that, and this last one is going to be f prime of g of x times g prime of x. Okay, so these are all equivalent ways of writing them, alright? And then another way to write it is that we have our dy dx on the left side here, and then here we have df du, okay, because this is what that represents, is that this is taking the derivative of f with respect to u, alright? And then this is also multiplied times u prime, and this is u prime of x, alright, because u is a function of x. So this could be du dx, because we're taking the derivative of u with respect to x, alright? And then lastly we have df dg, okay, and then times dg dx. Alright? So this is kind of more or less just a way of different ways of writing them, and this is how it works out, because when you have things like this second like term here, we have df over du times du over dx. So these du's essentially, they kind of, you can consider them like they cancel out, and overall you just get the derivative of the function with respect to x, which is really what we want, right? The derivative of the function, of the given function up here, with respect to x. So all of these are ways of going about it, alright? So we're using, just something to note is that we're using u or g, both functions of x, so are both functions, u and g are both functions of x directly, and they're being used as a kind of like a pathway. So they're used as a middleman, I'll call them. Okay, so middleman to get, screen's going here, to get from our initial function y, or f of something, or f, so to get from y to our x ultimately. Okay? So u and g are kind of just stuck in the middle, and we have to deal with them accordingly. Alright, so now what I'm going to do is write what so our next activity is going to use the chain rule to rewrite already known functions, to rewrite known functions. Okay, so what do I mean by this? So, for example, one of the functions that we already know is how to differentiate x to the n, right? But now, let's say, what if we were to have a function raised to the n power? What do we do with that? So if we ddx this, we're going to get, so the outside function is that something is raised to the n power. So we're going to kind of just take this exponent, stick it down in front like we normally do, so n times g of x to the n minus 1. And then, by chain rule, we have to differentiate the inside function as well. So then we're going to do g prime of x. So that kind of just tacks it on to the end there. Okay, so this is a more like, not advanced, but just a little bit more complicated version of the power rule, okay, using the chain rule as well. Okay, so another one that we do know is e to the x. That one's a pretty simple one, right? Because we know that e to the x is just, the derivative of that is just going to be e to the x again. But let's say we have e raised to g of x. So that's a little bit different, right? It's not just an x sitting up there. So what do we do with this? Let's ddx it. So our outside function is going to be e raised to some power, right? So we're basically just going to get e raised to that same power, and according to the chain rule, because we have this inside function here, we're going to multiply that times g prime of x. Okay, so you might start seeing a trend in that the chain rule is basically just tacking on this extra g prime of x, or the derivative of the inside function, which that's basically what it is. Okay, so let's say something else in a more general sense. You have some function f of x, okay? But now let's say we want to take a function that doesn't have x plugged in, but a kx plus b plugged in. So that's a linear or something inside, right? So this is our outside function is f, and our inside function is some kx plus b, which is, we can name it g, which is our inside linear function, okay? Let's say we were to take the derivative of this. What should we do? So we're going to take the derivative of the outside one, so we'll have our f prime, and we keep the inside the same, so we're going to keep our g of x, which is kx plus b, and then times the derivative of the inside, and since this is linear, we're just going to pull out the slope, so that'll be a k. Alright, so these are some cases of kind of rewriting formulas that we already know for the derivative, and we're incorporating the chain rule in them. Okay? Alright, so that wraps it up for our chain rule video. I hope that helps, and good luck on your homework.
Hey. Niggas, please be focused. That Bino, you know this. He rep the homososis. You know I'm from that zone 6. You know I rep